Now we are going to talk about a public key authentication. So in our previous lecture we have seen secure mutual authentication protocol using symmetric key, right? But can we do it with public key? So maybe you remember these things. So just check the previous things like we can use this curly bracket. So it means that message M is encrypted with Alice public key, and we can sign with Alice private key. In that case we use this first bracket. So if we just encrypt and sign like this, it is actually cancel each other. So this means we are encrypting with Alice public key, then sign it with Alice private key. So in that case we will get the message. And also if we sign the message first and then encrypt it, and also we get the message, same thing. So anybody can do this public key operations, and only Alice can use her private key for signing. Okay, just remember this part. So let's think about this one. Alice, she sent the message, I am Alice. Then what Bob will do, Bob will send a message and encrypt with Alice public key, send it to Alice, and then Alice send that message to Bob. Okay, this is very simple, straightforward protocol. Okay, so what does this mean actually? So does Alice authenticate herself to Bob? Yes, because this is encrypted with Alice public key, so only Alice can decrypt it because she have the private key and send this to her. So then Bob will compare that these are and these are the same. So that means whoever sent this message or reply this message, she have the Alice private key. So that should be Alice. Okay. So the problem is, yeah, Bob cannot authenticate himself to Alice. So Alice don't know whether this is Bob or Trudy. So what can happen, instead of Bob, Trudy can send him some message, anything to decrypt. Send anything, any message to Alice. Okay. So this doesn't no, this is not secure. So we might need two pair of keys. Okay. So for like something for encryption or something for decryption. Okay. So let's think. Okay. So now again Alice send a message to him, Bob. Bob send a message, send a challenge R to Alice, and what Alice can do, Alice sign it with her private key and send it to Bob. So what Bob will do, Bob have the private public key, right? So Bob will decrypt it with Alice private public key, and he will get R. So he will compare this R and this R. So if these two are same, that means this is Alice, or Alice sent it. So the question is it secure? Okay, so it's the same problem, like if instead of Bob there is Trudy here, so Trudy can send him any message here and Alice can sign that. Okay, like he sent the message like Alice owe me $10,000, Alice can just sign it, right? So so this, we should not use the key for signing. Okay, so we need actually two pair of keys right now. Okay, so it is a bad idea to use the same key pair for both encryption and signing. So what we can do from our current perspective, we can use two pair of keys, so one for signing or verifying and one for encryption or decryption. Okay. So now there is another key came in front, that is actually session key. You always you heard of session key. So this is actually a temporary key, and it is being used for a short period of time. So suppose we are using this session key, so that means it should be a symmetric key for a particular session. Okay, and it can be used for confidentiality and also maybe for integrity. Okay, so that the damage might be limited if one session key is compromised. Okay, so session key also need to be secure. So how actually we use session key for authenticate using like a shared symmetric key. It's like a shared symmetric key. So Alice and Bob, they should share some kind of session key, and Trudy cannot break that authentication, and also Trudy cannot determine the session key. Okay. So if we use session key, we have to keep in mind these points. So let's see how it is works. So what we're doing here now, like Alice send a message to Bob with a challenge. Then what Bob will do? Bob will receive that R, put a key K, send it to encrypt it with Alice public key. So send it to the Alice. Then what Alice will reply? She will reply R plus 1 and K and encrypt it with Bob's public key. Okay, so how actually these things working? Okay. Like how Bob can authenticate Alice. Okay. So because Bob sent this message, so Alice need to be decrypted with her public key, sorry, private key, right? And she have the K here, and again with K, something with that challenge, she encrypted with Bob's public key and sent it to Bob. So this K, if this K and this K are same, then Bob actually can authenticate. Okay, this is Alice. Okay. So R is like a nonce, he said. Okay. So Alice is authenticate, and also because this is encryption, so we are assuming this is a very perfect encryption, so no one can break it. That means this key is secure. So we are telling this is the session key. Okay. So this key is secure. That is fine. Okay. But the thing is, Alice cannot authenticate Bob. Okay, so there is no mutual authentication here. So this is not secure. Okay, let's do it like this. So in previous slide we did the encryption. Now let's do it by signing. So Alice said I am Alice. Send a random challenge R. And Bob will do? Bob will use that session key and sign it with his private key. Send it to Bob. Because Bob have the sorry, because Alice have the Bob's public key, she can break it, decrypt it, and find the key and send it to Alice. So same thing, same problem remains here. Like this session key is not secure because if you have Bob's public key, so you can easily break this thing, right? So Trudy, in the meantime, today received this message, and because Bob's public key is public, so he can easily break this. So we can mutual authenticate. We can have mutual authentication, but the thing is, the key is not secure. Right? Let's think about this one. We'll first sign that message and then encrypt it. Okay. So Alice and I am Alice as random challenge. Then Bob will at first he will sign that message with his private key and then encrypt it with Alice public key. Okay. So what Alice will do? Alice will use her private key to decrypt it, and then use Bob's public key to find the key. And again with the random challenge with R plus one with the K, and encrypt it, sorry, sign it with her private key, and then encrypt it with Bob's public key and send it to Bob. So is this secure? Yes, because we are using encryption here. Okay, so no one can break it, because if you want to break this one, you need Alice private key, or if you want to break this part, so you will need Bob's private key. Okay, so that is not possible, so it is secure. Okay, and also mutual authentication is okay, right? Because this key is only the because this key is signed by Bob's private key. So whenever Alice decrypt it using Bob's public key, he will get the value of K. So in that case, and Alice is again sending K, so Bob can authenticate Alice. Okay. So this seems okay, right? What about if we encrypt first and sign it? So in previous slide, what we have seen, we have sign it and then encrypt it. But now we are encrypt it first and then sign it. Okay, so what will happen here? So it is also fine. Okay, but the thing is, because this is encrypted, signed by Bob's private key, so Trudy can use Bob's public key, or in this case Alice's public key, and she can get this part. Okay, but the thing is now, mm, although Trudy received this part, but she cannot decrypt it because she need actually Alice or Bob's private key. Okay. So it is okay, but we are assuming that this security or this encryption part is difficult to break. So in that case, this protocol is secure.